Right. Hello, all. Thank you for joining us. So, do some quick introductions first, I guess, before we crack on with the slide deck that we've got to present to you today. So, I'm Jonathan Lewin. So, I head up the HV monitoring business for EA Technology. So, covers everything from the oil diagnostics business through to forensic investigations, through to PD, partial discharge instrumentation, and our field services guys. I've got John Joseph with me who will introduce himself.
Hi, so I'm John Joseph. I'm the operations manager for oil diagnostics. So my focus is the oils business here at EA Technology.
Okie doke. So as we go through, I'll just cover off a little bit of background just for those of you who are new to us as a business. So we are primarily focused in the kind of electrical industry. So we've been in this field for well over 50 years. We were set up in kind of 1966 as part of the Electricity Council Research Centre. And from then we've gone through a number of different iterations of the business, if you like. It went privatised when the electricity industry did, and that's when we emerged as EA Technology. Since then, we've gone through a recent commercial buy investment program where we are essentially pushing forward with our facilitation through to transition to net zero. So all our kind of products and services are there to support the industry in looking after their assets, managing their assets, and really monitoring that network going forwards. So the aim of what we try to do is create safer, stronger, and smarter networks. So primarily that is through monitoring and presenting that monitoring into insights. So we help to keep the power on safely as possible. We allow networks and equipment to be managed and to be run in a cost-effective way, so you get the most out of the electrical network and the infrastructures that are around you. Prevent catastrophic failures. Obviously, those units go off, power goes down, manufacturing plants stop, issues with homes and power. So there's a lot of financial losses to do with those. So we obviously play a big impact in making sure that the power does stay on. So we are a international business. So obviously here, me and John are at our headquarters in Capenhurst, just north of Chester in the UK. But we have offices in the US, in Australia, Singapore, covering across the globe. So we do play in a lot of different areas, from network operation companies through to industrial and private networks. So before we jump into the oil part of the presentation, just touch a little bit on some recent developments that we've done in our PD space. So the UltraTev, which a number of you will be familiar with, we've recently done some enhancements to the applications. So all these boxes you see around the instrument are all the devices that go with that as ancillary units, and our recent new ancillary component is the UltraBolt, which is the one down in the bottom corner. So that essentially replaces a standard bolt in the switchgear panel, and we can clip onto that using the UltraTev and take a direct TEV reading using an ultrasonic sensor inside the switchgear panel. So part of those recent upgrades for that particular application is looking at flexible surveys. So we've added different asset classifications, so you can set your surveys up with the asset classifications for your switchgear panels, things like that, so that you're assessing the right components that you're looking at. We've got an AI data-driven analytics on the screen now, so you'll see that in the top corner. And we've moved into the advanced analysis, so time frequency TF mapping. So I'm not going to go into that in any detail other than that. There's plenty of webinars that have come before this one, so a couple on the screen. So if you are interested in that, you can scan those QR codes and have a watch of those. Myself and John did a previous webinar on oil diagnostics and data-driven asset health. That's the one in the bottom right. So again, if you want some more generic information around oil and how we use it for determining assets and the data, scan that one and have a watch of that one after this one. So I will pass over to John, who's going to go through the contents around the PCB area and cover off that for you.
Okay, so for today's presentation, it's broken down to 4 sections. So I'm going to cover initially what are PCBs, following from that, look at the health, safety and environmental concerns around PCBs. Thirdly, the UK regulatory framework that impacts most of you on this call today, everyone in the UK. And finally, we'll look at sampling, testing and classification, and then finish with a Q&A on that. So what are PCBs? So specifically polychlorinated biphenyls, PCBs. These are a synthetic organic compound, which is a somewhat confusing designation, but it's a man-made compound. These don't occur in nature. Historically, these are commonly used for our industry as a coolant and insulating fluid within electrical assets. Also has been used as a lubricant and in industrial purposes, due to its elasticity, solid PCB is used as a plasticizer and additive as well in various resins and plastics. The primary properties of PCB, again for our industry, excellent dielectric properties. It's got a high ignition temperature and it's classed as non-flammable, and it's chemically stable as well. It's like chemical stability, which is the biggest issue from an environmental point of view today. So looking at a key timeline of PCB. So PCBs were first synthesized over in Germany at the back end of the 19th century. First commercially produced in 1929 over in the United States. During production, there were several nations involved in producing PCBs. The United States was the largest producer, accounting for about over half of global production during that time frame. Between the 1930s and 1970s, PCB liquid was, or PCBs were commonly used in electrical assets and industrial products. From the 1970s onwards, scientific evidence came to light of the toxicity issues and environmental issues around PCBs. And following on from that, we saw the first ban of PCB production over in the United States in 1979 with the Toxic Substances Control Act. And then other nations followed suit shortly after that. Britain brought in its own ban in 1986 on its use in electrical assets. During its production run, PCB was sold under a whole ruck of different commercial trade names. Within the UK, we had Araclor, Ascarol, Soval, and Sovalan were the common trade names. Other nations had other names. So the thing to bear in mind with PCB liquid in electrical assets is that PCB wasn't an additive, it was an insulating fluid. In the same way you've got mineral oil, you've got Midel, silicon, FR3. You had historically PCB liquid being used as an insulating fluid. The problem we have in the UK, globally, is that the same containers and vessels that were shipping mineral oil one way were also being used to ship PCB liquid at the same time. And as a consequence, our mineral oil stock got contaminated with PCB. Because it wasn't an intentional additive, we don't know where it is unless we test for it on the network. So how does PCB get into your asset? Well, it's either filled initially with PCB liquid or with PCB contaminated fluid at manufacturer. It contains PCB filled components such as capacitors, for example. It was retro-filled with PCB contaminated oil, or some contaminated equipment was used at some point during treatment or remedial action on that asset. So at the bottom of this slide here, we have got a list of general guidance assumptions. These are industry standard, accepted by the regulator. It's what the DNOs used on their impact submissions to the regulator. I would say the regulations themselves don't actually house these dates, but they are commonly acknowledged. based on our understanding of that contamination profile. So generally, any asset manufactured pre-1976, you should assume that it does contain PCB contamination. Anything manufactured between 76 and 86, so up until the UK ban, may contain PCB contamination. And any asset manufactured after 86, or installed after 86, it's reasonable to assume that's PCB free unless you've got evidence to the contrary on that. So from there, we'll move on to health, safety, and environmental issues. So we will start with the health effects. So when handling PCB or PCB contaminated liquid, the main exposure risk there is dermal absorption. So that's absorption of the compound through the skin or through the eyes. Other exposure means are inhalation of aerosols or vapor if hot working, or ingestion if you're not following good hygiene or eating on site. The acute effects that are well documented from PCB exposure. So at the milder end, you can have skin and eye irritation due to its dermal toxicity, and that can develop into what's called chloracne, which is a form of acne associated with PCB exposure. At the chronic end of that, there is evidence PCB has been linked to cancers, to liver damage, and to reproductive impacts as well. The issue with PCBs in the body, whether that's human body, animal body, is that PCBs are they're fat soluble or lipid soluble, not water soluble. So if you get it in the body, it's absorbed into the fat tissue. It's not passed through the urine, and that's why in the fatty tissue in the muscles you can get cancers. In the fatty tissue of the livers, you get liver damage. In the womb, you get womb issues there. On the right-hand side there, there's a list of effects that the CDC over in America has observed during animal studies into PCB, and it's quite a long list. So considering the exposure risks, so skin contact, inhalation, and ingestion, if you're dealing with pure PCB liquid, you want to block off all those exposure routes with your PPE. So that's wearing full industrial grade overalls, disposable ones, no pockets, hooded, non-permeable, and with elasticated wrists and ankles as well. You want to wear protective footwear, industrial rubber gloves, gauntlet style, comes up to the elbows ideally, and a respirator, and if not full face respirator, at least half face plus goggles as well, as the image on the right demonstrates. That's for handling pure PCB. So now moving on to the environmental issues around PCB. So the PCBs are highly persistent due to their chemical stability and resistance to heat and biological degradation. They stick around in the environment for a long time. They're not quite classed as forever chemicals, but they are not far off that. They strongly absorb to soil and sediment in the ground. And once absorbed into soil and sediment, they're easily transported through rivers. They can be carried as well on winds during storms as well. And finally, when it comes to fish and mammals, the compound, it does bioaccumulate in the fat tissue of the body, and also there's an effect called it biomagnifies. So this is when you see increasing levels as you go higher up the food chain. It increases in quantity in the body. For those handling it, the primary issue is absorption. For the general population, evidence does suggest that 90% of exposure does come from food that we eat, because it is in the soil and it's getting into the vegetation and the animals as well. Small spills, kind of outsized long-term impacts if not properly contained. So the problem if you spill PCB liquid or PCB contaminated liquid, it'll continue to leach those PCBs into groundwater long after that asset responsible for that spillage has been retired. And this process can cause pollution hotspots that remain hazardous for generations to come. And that's not theoretical. There are today pollution hotspots that exist across this nation. From an ecological standpoint, effects that have been seen is reproductive failure in birds, immune suppression in fish, and developmental toxicity in mammals. So yeah, quite catastrophic environmental effects there. What I've got here on this slide is a snapshot of news headlines from the past 2 years dealing purely with PCB contamination and the effects. So it is an issue that is very much in the news these days. So from there, we'll move on to the UK regulatory framework on PCBs. So the regulation that we're all beholden to is the Environmental Protection Disposal of Polychlorinated Biphenyls and Other Dangerous Substances, England and Wales Regulations 2000. It's quite a long title. That is the national regulation. There is also the supranational regulation. So there is regulation at the European Union level, which we took in our statute books in 2020. There is also the international regulations, which is the Stockholm Convention 2001. So there is a global effort to remove PCBs from the planet, but this is the nationwide regulation specific to ourselves. This came into force on the 5th of May 2000, and there's been a few iterations of that regulation over the years. But going through it, you end up with 3 key deadlines to be met. So by the 31st of July 2000, no person should be holding an asset that's PCB contaminated or suspected to be without that asset being registered with the Environment Agency. By the 31st of December 2000, any asset with PCB content greater than 500 parts per million by weight should have been removed from the network by that date or treated to bring the level down to an acceptable point. And the next deadline coming up, which is the title of this webinar, is the 31st of December of this year. And by that date, no PCB contaminated electrical equipment will be permitted to be used beyond that date. That has to either be removed or treated by then. Going to the regulations, a few pages in, you have the whole list of interpretations. So to confirm, contaminated equipment is classed as anything containing PCB concentrations above 50 parts per million, and equipment is defined as any equipment. So it's not just transformers. There's examples of equipment, but it's very clear any equipment is covered by these regulations. So taking those thresholds, you end up with these 3 action positions, basically. So if you've got an asset that has a concentration of PCB of less than 50 parts per million, that's classed as non-PCB equipment. You're allowed to continue using that equipment. The only thing to keep in mind is to keep records of the PCB certificate. So if you do get asked, you can demonstrate that asset is good to be used. Between 50 and 500 parts per million by weight, that asset is classed as PCB contaminated. That asset is allowed to be used up until the end of this year, at which point it has to be decontaminated or disposed of. Failure to do so is classed as an offence under the offence section of the regulation. Above 500 parts per million, that asset is classed as being highly contaminated. It's not permitted to be used, so that asset is historically banned from use, and that should be decontaminated or disposed of immediately as an asset. So from there, we'll move on to sampling, testing, and classification on your PCB tests. So before that, a quick overview of good practice when handling used insulating oil. And this is irrespective of PCB contamination. There are other materials that could be in there, such as heavy metals or high gassing that can be an irritant. So when handling used insulating oil, it's always important that strict hygiene is followed. So that includes washing exposed body parts following work, not eating, drinking, or smoking in the work area, and avoiding wiping the face as well with oily hands, and using clean paper to do so. In terms of sampling for your PCB analysis, if you're just doing a PCB test, very low volumes of oil required. It's a few grams we use in the test itself. For large-scale PCB testing programs, the lab, we do supply to clients 10 ml dropper bottles, so they are very practical as a way of getting a sample out, as illustrated in that image there. Due to the stability of PCB as a compound, sampling practice to a large extent isn't as critical as you find for other tests, such as dissolved gas analysis, where you don't want to disturb the gases, moisture and breakdown, we're trying to avoid contamination of the fluid. PCB doesn't exist in the environment, so you won't contaminate it. It's very stable, so you won't disturb it. The only thing we ask for is you send us a sample of the oil itself. We don't want samples of water and debris, so methods aren't developed for that. And obviously, for an accurate PCB certificate after the test, make sure you supply the laboratory with the full asset details as well. So asset ID, serial number, manufacturer, etc. And the final note is the PCB is classed as a one-off test. So once you know the PCB content of your oil, that will not change for the life of that asset unless you do an oil change on that asset. It's very stable as a compound. And then when it comes to the actual laboratory analysis, so that's done in accordance with IEC 61619. As a lab, we've got 4 gas chromatography with electron capture device instruments for PCB testing. 2 of those instruments are dual injectors, so we can run 2 samples concurrently. So we call it 6 instruments in the lab. The preparation method we utilize is a liquid to liquid extraction. There's an option for liquid to solid, but it's not the preferred method. And extraction is using sulfuric acid and trimethyl pentane as well for clean extraction of the PCB from the mineral oil. That extract is injected into the GC-ECD system. It's done automatically by the instrument. And from that, we identify the presence of PCB using the peaks on the chromatograph. And the peaks are determined by the retention time, so how long it takes for that compound to run through the column of the instrument. Fortunately, the analysis is also quantitative, so it's not just confirming the presence of PCB. It'll tell us how much PCB is present by the height of that peak relative to the calibrant we are using. And from all that testing, we've come up, with these 3 classifications based on what we saw earlier. So less than 50 parts per million, we give that a green as a lab, that is non-PCB contaminated. Between 50 and 500, we give that an amber, that's PCB contaminated. Above 500, we give that a red, and that's highly contaminated. And that's the traffic light system we use, and I'm sure many labs use on PCB testing. Also to note on that, many of the oil reclamation businesses won't accept oil with PCB content greater than 10 parts per million for recycling purposes. So that's something to note. The reports themselves should be clear, precise, and accurate. Should detail very visibly the asset that samples come from, what the PCB results are, the standards to which that test is being run, and any subsequent comments and recommendations on those results. So on this next slide, left here is an example of a PCB report. So as a lab, as you can imagine, we get through a lot of oil. We do separate out the PCB from non-PCB waste, but we do still test our non-PCB mineral oil for PCB contamination before it's disposed of, and that's one of the certificates from that test. On the right is a snapshot from our online portal where we have got the PCB value for an asset up front with the asset information, very visible and easily accessible as well. So that covers everything on PCB. As a final thing here, I've got a short 1-minute video demonstrating the client portal, which we've currently built and are rolling out now to our clients. So that's a online platform for viewing all oil results, not just PCB. If anyone's interested, drop us an email, and can demonstrate that to you. So from there, we'll move on to question and answer. I know it's a subject that touches questions, legal questions, which I'm definitely not qualified to answer. I probably still will answer them, but I shouldn't be answering them, so don't ask those. But ask away. Have any questions? Yeah.
In that case, we've got a question here from David. Thank you for your question, David. Hi, gents. Is there a requirement to sample assets newer than was it 86 to PCB content? So I think you mentioned in one of the slides that there was, is it after 1986?
Yeah.
There's
So,
content.
yeah, you're unlikely to have contamination in there, but the only way to legally confirm that is to have a PCB content. Typically, if it's beyond that period, you can wait, but anyone that's doing any remedial treatment or going near that asset is likely to want to know or confirm that it's got a PCB content within a safe level, really. So the answer in short is yes. The best practice would be to, if you get any asset with any oil in it, is to have a PCB result so that you're comfortable, you can confirm that your engineers or anyone who's going near or around that asset is essentially safe to do so. Okay. So we'll just give it another minute just in case there's any other questions pop through. But like I said, you've got QR codes earlier on. The presentation slide deck will come around to you all anyway. And if you want to look at any of those previous webinars, please do. Please feel to do so. And if you do have any other questions that pop up after we finish today, do just send them through to us and we can answer those for you. Okay. So we'll look to wrap it up there. So thank you all for joining us, and hopefully it's been informative for you, and hopefully we will see you all on the next one.
Thank you all.